In a single sweep through 4 years of NASA telescope data, an AI built at the University of Warwick just confirmed 118 brand new planets, and flagged nearly 1,000 more that humans had missed entirely. And one of those discoveries shouldn't exist at all, by every law of planetary physics we know. I'll show you exactly where they found it before the end. Here's the thing about hunting planets. Humans have only confirmed about 6,200 exoplanets in the 3 decades since the first one was found, and the current best estimates say there could be trillions in our galaxy alone. The reason for the gap is brutal. NASA's TESS satellite stares at the sky and watches for tiny brightness dips, sometimes less than 0.1%, every time a planet crosses in front of its host star. 4 years of TESS data covers more than 2.2 million stars, each one producing tens of thousands of brightness measurements. A human astronomer simply cannot read through that. Even with classical algorithms, the false positive rate is enormous, eclipsing binary stars, instrument noise, and background contamination drown out the real signals. Finding real planets in that noise is needle in a haystack, at planetary scale. And the bottleneck isn't telescope time anymore. We already have the data. The bottleneck is human attention. Astronomers spend years manually validating each candidate, running follow-up observations, computing radial velocities, ruling out imposters. By the time you finish vetting one batch, the next satellite has dumped another terabyte. Meanwhile, the universe just sits there, with potentially trillions of unconfirmed worlds. Some of which are in places we don't expect, orbits so close to their star that conventional models say no planet should physically survive the heat. We've been missing those, because we didn't have time to look. This is exactly the pattern recognition problem machine learning was supposedly built for, and until last month, nobody had actually deployed it at this scale. Which brings us back to that AI at Warwick, and the 118 new planets that just appeared in our catalog from data we already had. The system is called RAVEN, short for Ranking and Validation of Exoplanets. The team trained it on hundreds of thousands of simulated planet detections, mixed with the known false positive patterns from previous Kepler and TESS catalogs. Then they pointed it at 4 years of TESS data covering more than 2.2 million stars, focusing on planets with orbital periods under 16 days. The result, published in MNRAS, is one of the largest single AI-driven confirmation efforts in exoplanet history. 118 brand new validated planets. Over 2,000 high-quality candidates flagged for follow-up, and nearly 1,000 of those candidates had never been spotted by any previous pipeline. But the headline finding is the strangest one. Hundreds of these planets sit inside the Neptunian Desert, a region so close to a star that Neptune-sized planets shouldn't physically survive the heat. Around just 0.08% of Sun-like stars are predicted to host these. RAVEN found them anyway. Which means our physics models for planetary migration might actually be wrong. The bigger implication is the speed multiplier. RAVEN achieved validation uncertainties up to 10 times smaller than what was possible with the previous Kepler-era pipelines, and it did it in days instead of years. Apply this same architecture to the upcoming missions, the European Plato satellite, NASA's Roman Space Telescope, ground-based surveys with millions more stars on the way, and the catalog of confirmed exoplanets could realistically grow by an order of magnitude within a decade. The bottleneck moves from astronomers to compute, which means the question stops being how many planets exist, and starts becoming which of them are habitable. So here's the real question worth sitting with. If a single AI can find planets we didn't even know how to look for, what else is already in our existing data, waiting for the right model to read it? Every telescope archive, every protein database, every climate record going back a century. All of it is sitting there, ready to give up the discoveries we couldn't see ourselves. The science isn't gone. It's just unread.